Hello and welcome to another video in a series of videos on the AQA A-level Chemistry Paper 3 or Component 74053. This specific video is on the 2021 paper and I'm going to be providing an explanation to each of the multiple choice questions. The likelihood is if you're watching this video you're looking for a specific question or a specific explanation, so I've added in chapters or timestamps so you can just scroll to the relevant question. Question number 7, which does not involve the absorption of UV or visible light. Statement A, the fact that copper 2 sulfate appears blue is because it's absorbing certain wavelengths of light and transmitting or reflecting blue. That's how most colour is seen, or all colour is seen I should say, so that is a correct statement. The breakdown of ozone in the upper atmosphere, you learnt this in the haloalkanes topic, so ozone is broken down to form oxygen, and the ozone breaks down as it absorbs UV, so that is also a correct statement. C is an incorrect statement, we'll come back to that in a minute. Just eliminate option D first. So chlorine would not normally react with methane at room temperature. However, you will get a reaction where the chlorine and a hydrogen swaps around. That's free radical substitution, involves the absorption of UV light to form two chlorine radicals. Statement C is the one that's not correct. It doesn't absorb UV light or visible light, and that's because in ionization in a mass spectrometer, ionization occurs via electron impact, so high energy electrons are fired at a sample, or electrospray, where the sample is dissolved in a volatile solvent, passed through a high voltage needle and gains a proton. Neither of those involve the absorption of UV or visible light. So C is the correct answer here. Question number 8. Which statement about chloride ions is not correct? So statement A, will it form a white precipitate when you add silver nitrate? Well, you should remember that you get a white precipitate of silver chloride formed, which does dissolve in aqueous dilute ammonia. So statement A is correct. Statement B, do they form an octahedral complex when aqueous cobalt ions, remember if you've got an aqueous transition metal in solution, it exists as the hex-aqua complex. When that reacts with an excess of chloride, would your complex be octahedral? It wouldn't be octahedral because chloride is a bigger ligand than water. So you'll only get 4 chlorides fitting around the transition metal. So it becomes tetrahedral, not octahedral. Statement C, when chlorine reacts with potassium bromide or bromide ions, chloride ions are formed. That is a correct statement. Chlorine is easily reduced, so it easily gains electrons, or it causes the bromide to be oxidized. Chlorine is a stronger oxidizing agent than bromine, so therefore this reaction will occur. Statement C is correct. And do chloride ions have the electron configuration seen there? Chlorine is in period 3, group 7. So chlorine 1s2, 2s2, 2p6, 3s2, 3p5. When it becomes chloride, it gains an electron and becomes 3p6. So that electron configuration is correct. B is the incorrect one, so B is the correct answer. Question number 9. What is the mole fraction when you have 1 gram of a compound, and you're told it's MR, dissolved in 30 grams of a solvent of relative molecular mass 50? So firstly, let's work out the moles of the compound. Moles of the compound, you've got the mass, you've got the MR, so it's 1 over 100, or 0.01 moles. What's the moles of the solvent? Moles of the solvent, you have 30 grams divided by its MR of 50, so 30 divided by 50 is 0.6 moles. The mole fraction for the compound is the moles of the compound, 0.01, divided by the total moles. So 0.01 plus 0.6. So what's the mole fraction? Plug that into your calculator and you get an answer of 0.016 or 1.6 times 10 to the minus 2. B is correct. Question number 10, which has the electron configuration of a noble gas. So for something to have an electron configuration of a noble gas, it would be an S or a P block element as its stable ion. H plus has lost an electron, that has no electrons in it. So obviously that one is not got the electron configuration of a noble gas. O minus isn't the oxidation state of its stable ion. So O minus, oxygen normally ends in 2p4, this ends in 2p5. So it's got the electron configuration of fluorine. Se2 plus, 2 minus has 34 electrons when it's selenium. When it's Se2 minus, it's going to have 36 electrons. That's the stable ion for a p block element. Which noble gas has 36 electrons? It's krypton. Transition metals, when they become ions, they will lose their 4s electrons first. So Zn2 plus normally has 30 electrons. So it normally ends in 4s2 3d10. When it becomes its stable ion, it just loses its 4s2 electrons and ends in 3d10. So that's not got the electron configuration of a noble gas. Question 11. Another statement where it says which one does not support the suggestion. So therefore you have to go through all of them and eliminate all of the correct answers. So hydrogen NMR, does this compound have 3 peaks with an integration ratio of 2 to 3 to 3? So in the hydrogen NMR or proton NMR spectrum, there's 1 peak, there's 2 peaks, and there's 3 peaks, or there's 3 different hydrogen environments, 3 hydrogens in that environment, 2 hydrogens in that one, and 3 in that one. So it would have 3 peaks with that ratio. Does its carbon NMR have 3 peaks in the spectrum? So does it have 3 carbon environments? So I'll circle each one of the carbon environments. There's 1 carbon environment, there's its second carbon environment, there's 3, and there's 4. So there are 4 different carbon environments. Notice there's no symmetry. So there'll be 4 peaks, not 3 peaks. So statement B is the incorrect statement there. Just going through C and D, we'll just eliminate those. Will it have an absorption of 1735? Well, it will. If you look on the data sheet, the C double bond O in the compound will cause it to have a peak between 1680 and 1750 per centimetre. And statement D, you're going to need your calculator for this one. Does it have a percentage by mass of oxygen being 36.36 and 9.09 by mass of hydrogen? So for this one, you're going to need to work out the percentage by mass of firstly oxygen and secondly hydrogen. So percentage by mass of oxygen, we have 2 oxygens, so 2 times the AR of oxygen divided by the MR of the whole compound. So the MR of the whole compound is 88, and then times your answer by 100. Percentage by mass of oxygen will come out as 36.36%. Percentage by mass of hydrogen, we have 8 hydrogens. Hydrogen's AR is just 1, so that's 8, divided by the MR of the whole compound times 100, and that comes out as 9.09%. So therefore statement D is also correct. Question 12. Which statement is always correct about inorganic ionic compounds? So, do they dissolve in water to give neutral solutions? Well, they can be neutral if it's a salt. So ionic compounds can dissolve in solution to become neutral. But ionic compounds could also be acids, so HCl, break up into its ions. That's going to have a pH of less than 7. Sodium hydroxide is ionic. It's going to have a pH of more than 7 when it dissociates. So that statement is not always correct. Do they release energy when they melt? Well, when you melt something, you're breaking ionic bonds, breaking the strong electrostatic attractions. If you're breaking bonds, that's going to require energy, not release energy. So that's an incorrect statement. Do ionic compounds always contain metal cations? So metal cations like your sodium, so you could have sodium chloride, you could have potassium chloride, calcium chloride, etc. They often contain metal cations, but cations can also be made up of non-metals like ammonium or hydrogen. So they will not always contain a metal cation. So hopefully D is correct because we've eliminated the other three. Do they form giant structures? Yes, they do. They form giant ionic lattices with no fixed formula, just alternating arrangements of positive and negative ions. So D is the correct answer here. Question 13. Which species has a lone pair of electrons on the central atom? So carbon forms 4 bonds, oxygen forms 2 bonds. So that's no lone pairs on the carbon because all of its outer electrons are involved in bonding. Sulfur dioxide, so sulfur's in group 6. Oxygen forms 2 bonds, so each oxygen forms 2 bonds. Sulfur's formed 4 bonds, so there would be a lone pair left over. So SO2 does contain a lone pair. PCl6-, it's got a negative charge, so if it's got a negative charge it's got 1 extra electron than normal. So if you put PCl6- as your answer, phosphorus is in group 5, it's formed 6 bonds with chlorine, so therefore what you're going to have is 6 bonding pairs, no lone pairs. And again, the reason phosphorus can form 6 bonds and not 5 bonds is because it's got an extra electron that can be involved in bonding. SO4 2-, oxygen will form 2 bonds. So 2 of the oxygens in SO4 will form 2 bonds. And because it's got a 2- charge, there are 2 extra electrons. So these 2 oxygens only need to form 1 bond. The sulfur has formed 6 bonds, so therefore there are no electrons on the central atom. Question 14. In which substance do covalent bonds break when it melts? So we have hexane, ice, iodine and silicon dioxide. Covalent bonds are very strong, require a lot of energy to break. So hexane, ice or water, and iodine are all molecular substances. That means you're going to be breaking weak intermolecular forces between molecules when it melts. The covalent bonds will stay intact. Silicon dioxide, also known as silica, is a macromolecular structure. So when silica melts, you're breaking many strong covalent bonds. So D is correct here. Question 15. In which molecule are all of the atoms in the same plane? So we're looking for planar structures where the whole thing is planar. In A, you have CHO, it's an aldehyde, specifically ethanol. So the C double bond O group is planar, but it's also got a CH3. And you should know that if carbon's got 4 bonding pairs, you're going to have your tetrahedral structure around that CH. So even though that's planar, the CH3 group attached to the C double bond O is not planar. So that's in 3D. Again, you have a CH3 group around in methylamine. So you're going to have your tetrahedral structure here. Bonded to your nitrogen. Nitrogen has 1 lone pair. So you're going to have your pyramidal structure. So none of it's planar around methylamine. You have chlorobenzene. You should be aware that benzene is a hexagonal planar molecule with a ring of delocalized electrons above and below the plane, and the chlorine is bonded. So C is correct. That's a hexagonal planar molecule. Let's just eliminate option D. Again, we have our planar benzene ring, but we have a methyl group coming off it. Methyl group makes the molecule no longer planar because it's got 4 bonding pairs, and that's a tetrahedral structure around the methyl group. So the only one that is completely planar is chlorobenzene. Which molecule has a permanent dipole? So in order for it to have a permanent dipole, the molecule has to be asymmetric. So for it to be asymmetric, it's going to have either different atoms bonded around the central atom, which none of our options do, or there's going to be a lone pair. That will distort how the electrons are arranged and therefore make it polar and therefore make it have a permanent dipole. So BF3, boron's in group 3, it's got 3 bonding pairs, no lone pairs, that is non-polar overall. NH3, nitrogen's in group 5, it's formed 3 bonding pairs, so 3 of its outer electrons are involved in bonding, so therefore there's a lone pair left over. That means NH3 has a lone pair, ammonia is a polar molecule. Just go through C and D. Silicon is in group 4, it's formed 4 bonding pairs with chlorine. All of the same atoms bonded around, the polarity will cancel out, that's non-polar overall as well. And finally SO3, oxygen forms 2 bonds, sulfur's got 6 outer electrons, so if all of the oxygens are double bonded, all 6 of sulfur's electrons are involved in bonding, the polarities will cancel out, the dipoles cancel out, that is non-polar overall as well. Question 17. Which statement about this carboxylic acid is correct? In aqueous solution it reacts with magnesium to form carbon dioxide. So carboxylic acids do indeed react with magnesium and other reactive metals, but it won't produce carbon dioxide. Metal plus acid, you're going to form your carboxylic acid salt, and you're going to get hydrogen gas given off, not carbon dioxide. Do carboxylic acids form hydrogen bonds? They do indeed form hydrogen bonds, as you have your electronegative oxygen bonded to a less electronegative hydrogen. So you can get hydrogen bonds between the delta positive hydrogen and an oxygen on an adjoining carboxylic acid. So that can be the oxygen in the OH, or it can be the oxygen in the C double bond O. So it will form hydrogen bonds. That's our correct statement. Does it have optical isomers? So just drawing this out, are there any carbons with 4 different groups attached? So we have 1, 2, 3, 4 carbons in a row. You've got 2 hydrogens on the second carbon. You've got 1 hydrogen on the third carbon, but you have 2 methyl groups. So obviously if it's got more than 1 hydrogen it can't have optical isomers. This carbon here that I've just circled has 2 methyl groups, so that can't be chiral. And the COH only has 3 different groups. So no chirality, therefore no optical isomers. Does it have the IUPAC name 2-methyl butanoic acid? So carbon 1 is always where the carboxylic acid is. You've got carbon 1, carbon 2, carbon 3 and carbon 4. The methyl group's actually on carbon 3, not carbon 2. So statement D is incorrect. Question 18. Mixture of 2 decimeter cubed of hydrogen and 1 decimeter cubed of oxygen is mixed together at room temperature. So if you had a bottle containing hydrogen and oxygen, as long as it's at room temperature and kept cool, these two will not react together. The reason why is because when they collide into each other, they're not going to react because they're not colliding with sufficient energy. you need some sort of activation energy, some sort of spark in order for this reaction to occur. There's a relatively high activation energy, so statement A is correct. It doesn't matter about frequency of collisions, it's frequency of collisions with the activation energy or greater. So statement B, not quite correct there. Is the mean velocity of hydrogen molecules less than the mean velocity of oxygen molecules? Well, the speed at which the particles are moving around is dependent on temperature. So they're going to have the same mean velocity there. So statement C is incorrect. And are the partial pressures of each gas the same? Because you have 2 decimeter cubed of hydrogen, 1 decimeter cubed of oxygen, the partial pressure of hydrogen will be twice that of oxygen because you've got twice the volume. So statement D is also incorrect. Question number 19. Which statement about the distribution curve of molecular energies at a given temperature is correct? So this is referring to the Maxwell-Boltzmann distribution, which I'm just sketching out below. So statement A, no molecules have zero energy. That is a correct statement. The Maxwell-Boltzmann distribution at any temperature is going to start at the origin. Another way of saying that is all molecules will have at least some energy. No molecules will have no energy. The maximum is the highest point of the curve on the y-axis. So this is our maximum here. Is the curve symmetrical about the maximum? No, it's not. It's skewed to the right. If you were to change the temperature, it says that has no effect on the position of maximum. Well, the maximum, the bit that I've just highlighted, will be moved. So for example, if I was to reduce the temperature, the maximum moves to the left, which I've just drawn in there. If I was to increase temperature, the maximum moves to the right. Do most molecules have the mean energy? Well, the most probable energy is in line with the maximum or the peak of the curve. The mean energy is slightly to the right of that. So most molecules do not have the mean energy. It's slightly to the right of the maximum. Statement A is the only correct one. Question 20. Which statement about the addition of a catalyst to an equilibrium mixture is correct? Statement A. The activation energy for the reverse reaction increases. So if you've got a catalyst, adding a catalyst will lower the activation energy needed. So it doesn't increase, it would decrease. Does the equilibrium constant for the forward reaction increase? The equilibrium constant is K, so Kc or Kp you've come across. Kc or Kp are only affected by changes in temperature, so a catalyst would have no effect on the equilibrium constant. Does the rate of the reverse reaction increase? It does. It also increases the rate of forward reaction. So a catalyst increases the rate of the forward and reverse reaction by equal amounts. So statement C is the correct one. Statement D, you're not changing the enthalpy change for the forward reaction. The enthalpy change for a reaction, the delta H, is the same with or without a catalyst. The only thing that changes is it reduces the activation energy. So if you add a catalyst, activation energy changes, but delta H stays the same. So again, statement C is the only correct one here. Question 21. Which equation does not show the reduction of a transition metal? So A, you've got titanium 4 chloride, so titanium is 4+. It's going to titanium as an element, so it's going from 4+ to 0. Reduction is the gain of electrons or the reduction or decrease of its oxidation state. So it's going from 4+ to 0, it's reduced. In B, you're going from FeCl3, where the Fe has a +3 oxidation state, to FeCl2, where it has a +2 oxidation state. Again, the oxidation state is being decreased or reduced, or it's gaining an electron. In C, we've got MnO2, manganese oxide. The manganese would have a +4 oxidation state. It's going to MnCl2, where the manganese would have a +2 oxidation state. Again, the manganese is being reduced. So it's being reduced in A, B and C. Hopefully in D it's staying the same because we've eliminated the first three answers. So in cobalt oxide, our cobalt has a +2 oxidation state. In this complex cobalt chloride or tetrachlorocobalt, what's the oxidation state of the cobalt? Well, if each chloride is -1, we've got 4 chlorides. So how do you go from -4, which is the charge on the ligands, to -2? That will tell us the oxidation state of cobalt. -4 to -2, you're going to add 2. So cobalt stays as +2 oxidation state in equation D. Question 22. Which one contains delocalized electrons? Well, A is cyclohexane. No delocalized electrons there. It's just 6 carbons in a ring. Notice that's not benzene. Graphite. Graphite does contain delocalized electrons. Each carbon forms 3 bonds. You've got layers of hexagonal carbon atoms, and you've got delocalized electrons because each carbon forms 3 bonds per atom. Delocalized electron per atom that moves between the layers. Iodine is molecular, there's no delocalized electrons. Sodium chloride is ionic. There is electron transfer to make your Na plus and your Cl minus, but there are no delocalized electrons. Question 23. Which compound has Ez isomers? So the criteria for something to have Ez isomers is you must have a carbon-carbon double bond, and you must have 2 different groups on each carbon in the double bond. So A and B cannot be the same, and E and F cannot be the same. So we have 4 alkenes. A cannot have Ez isomers because one of the carbon has 2 hydrogens. B cannot have Ez isomers because each of the carbons in the double bond has 2 different atoms bonded. C, you have this compound here, where you have H and a Br on each carbon in the double bond. So because you've got 2 different groups on each carbon in the double bond, you do indeed have Ez isomers. So I'll just draw those out for you so you can see. So the bromines can both be pointing down or up, so that would be your Z isomer, and one bromine can be pointing up and one can be pointing down, that's your E isomer. And D cannot have Ez isomers because the left carbon has 2 bromines on, so C is the correct answer here. Question 24. Which polymer has hydrogen bonding between the polymer chains? So we have Kevlar, which is a polyamide. There's one on the specification you need to be aware of. PVC, that's polyvinyl chloride or polychloroethene. Polyphenylethene. So phenylethene would have the repeat unit of a benzene ring on one of the carbons and then hydrogens on the other carbons. So polyphenylethene would look like that. And terylene is a polyester. Again, that's on the specification. So which one's going to have hydrogen bonds? Well, our addition polymers, polychloroethene and polyphenylethene, do not have OH or NH bonds or FH bonds. So therefore they would only have van der Waals forces or dipole-dipole forces between chains. Polyesters for terylene, you've got your C double bond O, single bond O, that's our ester link, and you've got your R groups and your other C double bond O's. So polyesters, even though they've got a C double bond O and a single bond O, there is no OH bond. So it's polar, you will have dipole-dipole forces between chains, but there would be no hydrogen bonds. Kevlar is a polyamide. Polyamides have an amide link, CONH. Because you have an NH bond, you've got the large difference in electronegativity, therefore you would have hydrogen bonds between our polyamide. So answer A is correct. Question 25. Which compound needs the greatest amount of oxygen for complete combustion of 1 mole of the compound? So we have ethanol, ethane 1,2-diol, so you've got 2 OHs there, and methanol, CH3OH. Now the easy way to do this is just look at how many carbons and hydrogens you've got, and it's going to be the one with the most carbons and hydrogens on it. Will need the greatest amount of oxygen. The way to work it out in full is to complete or construct balanced equations for their complete combustion and work out which one has the greatest ratio of the compound being combusted to oxygen. So ethanol plus oxygen, you have 2 carbons, so 2 CO2s, 4 hydrogens, so 2 H2Os, and that's going to leave you with 6 oxygens in total, minus the one that's already in ethanol, so that's going to leave you with 2.5 O2. If we were to combust ethanol, again you've got 2 carbons, so 2 CO2s, you have 6 hydrogens, so you need 3 H2O. That leaves you with 7 oxygens minus the one that's already in ethanol, so you're going to have 3 O2 there. Ethane 1,2-diol, again we have 2 carbons, so 2 CO2s. We have a total of 6 hydrogens again, so we're going to need 3 H2O. There's 2 oxygens in the ethane diol, so 7 oxygens in total. Take away 2 will leave us with 5 oxygens left over, so we're going to need 2.5 O2 there. And finally, methanol plus oxygen, we are only going to make 1 CO2 and 2 H2O. There are 2 plus 2, 4 oxygens in total, minus the one that's there, so 1.5 O2. Which one needs the greatest amount of oxygen? It is ethanol. So B is our correct answer. Question number 26. What compound is produced when 1-phenyl ethanol reacts with acidified potassium dichromate? So if we add ethanol, CH3CH2OH, this will be carbon 1, where the OH is. So our phenyl group, our benzene ring C6H5, is going to be on carbon 1 as well, because it's 1-phenyl ethanol. So that makes this compound, 1-phenyl ethanol, a secondary alcohol. So I'm just going to redraw that. So if our COH is there, we've got a C6H5 on carbon 1 as well. Hopefully you can see a bit clearer that it's a secondary alcohol. So if it's oxidized by acidified potassium dichromate, secondary alcohols will become ketones. So we'll have this formula here, CH3, C double bond O, C6H5, which matches up there to compound C. It's just written the wrong way around, or the other way around. Now question 27, what's the correct general formula for non-cyclic compounds in each of the homologous series? If you don't know the general formula for different compounds, then it might help to just choose an example. So for example, let's say each of our molecules is going to have 4 carbons in. So if we add an alcohol with 4 carbons, we would have butanol. What's the general formula for that? Well, for every carbon, we're going to have 2 hydrogens, twice as many hydrogens plus 2, and an oxygen. So our alcohols, CnH2n plus 2O, is correct. Let's eliminate the other ones. So for an aldehyde, for B, if you had 4 carbons, you would have butanal. So butanal has the formula C4H8O. So the general formula would be Cn H2NO. So that one would be incorrect. Esters, let's choose ethyl ethanoate. Again, 4 carbons in it, which would have the overall formula, or the molecular formula, of C4H8O2. So therefore the number of carbons would be N, number of hydrogens is 2N, and we always have 2 oxygens in an ester. So it's not 2N plus 1, it's 2N. And finally, primary amines. So if we had butyl amine, for example, C4H9NH2, for every carbon we have twice as many hydrogens plus 3 and an N. So it should be 2N plus 3, not 2N plus 2. So that one is also incorrect. So A is the only one with the correct general formula. Question 28. Which compound forms a white precipitate when added to silver nitrate? So if you added bromoethane to silver nitrate, provided there is something to hydrolyze the carbon-bromine bond, then you would get bromide ions that would react with the silver ions. But you'd actually get a cream precipitate, not a white precipitate. Ethanol would not form a white precipitate. Ethanoic anhydride would not form a white precipitate. Acyl chlorides will react with the water because it's aqueous. You get a carboxylic acid and hydrogen chloride. So usually you get misty fumes, but because you're making chloride, the chloride ions would react with silver nitrate and you would get a white precipitate of silver chloride there. So D is the correct answer. Nitration of 1.7 grams of methyl benzoate. So methyl benzoate is an ester of benzoic acid. We're nitrating it, so we're adding nitric acid, and we're going to add an NO2 group on at carbon 3 there. So this is our overall equation. Writing it out just so you can see, but it is a 1-to-1 ratio of reactants to products. So if we had 1.7 grams of our reactant, we're told the percentage yield is 65%. What mass of the product is produced? So let's firstly work out the moles of the reactant. So you've got 1.7 grams divided by the MR of 136. That's 0.0125 moles. Assuming 100% yield, or assuming all of the reactants turn into the product, it's a 1-to-1 ratio, you would make 0.0125 moles of our product, methyl nitrobenzoate. Therefore, what is the theoretical or maximum yield of our product? So if we could make 0.0125 moles at most, multiply that by the MR of our product, which is 181, 100% yield would mean we would produce 2625 grams, and therefore if that's 100%, 2.2625, times that by 0.65 or 65% to tell us what we actually made, and that is 1.47 grams. So C is your correct answer here. Question 30. A 2-step preparation of an amine is shown. So you're going from bromoethane to propylamine. What is the intermediate compound X? So a big clue here is the fact that we're going from an eth, or something with 2 carbons in it, to a prop, or something with 3 carbons in it. The main way to increase the carbon chain from the specification is by adding a nitrile. So a nucleophilic substitution where you add a cyanide ion that attacks a delta positive carbon and the bromine breaks off. So, because we're going from eth to prop, increasing the carbon chain by adding cyanide. So therefore, our intermediate compound must have one extra carbon than bromoethane. So if we were to add potassium cyanide to bromoethane, nucleophilic substitution occurs. We would make propane nitrile. That can be reduced by using LiAlH4, and that will make our propylamine. That's one of the ways to make primary amines. B is our correct answer. Question 31, which compound reacts with warm dilute sodium hydroxide? So when sodium hydroxide is aqueous and warm, it's going to act as a nucleophile. So we're identifying which compound will undergo a reaction with a nucleophile. Benzene, the reactions you've learnt, benzene will only react with strong electrophiles. It's got a ring of delocalized electrons, it would actually repel the hydroxide ion. B, similar to benzene, you've got an alkene, C double bond C, that would repel the OH minus ion, it wouldn't react. C is a primary amine here. Amines do not react with the hydroxide ions, similar to the reasons above, in fact, because you've got a lone pair on the NH2, that's going to repel the hydroxide. This compound here, ethanoic anhydride, acid anhydrides react in the same way as acyl chlorides. They will react with nucleophiles. They usually undergo nucleophilic addition elimination. So they will react with hydroxides just like they react with water. And so you're going to form a carboxylic acid. So hydroxides and acid anhydrides, not technically on specification, but you know that hydroxide is a nucleophile. You know that these undergo reactions with nucleophiles. So D is the correct answer here. Question 32. Methylamine is going to react with bromoethane by nucleophilic substitution to produce a mixture of products. So this is a reaction where you will get further substitution. As long as the lone pair on the N is available, it will keep acting as a nucleophile, attacking the delta positive carbon, causing the bromide to break off. So methylamine is a primary amine. You will make a secondary amine where the ethyl group has joined on. A hydrogen comes off the NH2. So you would make ethyl methylamine. That will react further with bromoethane, apologies. You get another ethyl group joined on, so you'll have two ethyl groups. Another hydrogen will come off, and the methyl group will stay there. So you would make diethyl methylamine. That will attack one more bromoalkane. You will get a quaternary ammonium salt with the overall formula. So an extra ethyl group is joined on. So that will make the nitrogen positive, it's just formed a coordinate bond to C2H5. The bromide will be there. So you'll have triethyl methyl ammonium bromide. And we can see that one is given in answer D. So A, B and D are all possible products. C is an incorrect product because you will only ever have one methyl in the compound. So C is the correct answer here. What's the repeating unit of a polyamide for question 33? So polyamide, you're going to have a CONH. You need your amide link. And then you're going to have either one or two monomers either side of the amide link. So A is an amine, that's not an amide link. B, even though you've got an NH2, is an ester link. C, even though you've got an NH2, you've got a C double bondo, single bondo, so you also have an ester link there. Hopefully D has an amide link. You've got your C double bond O NH. You've got your C double bond O on one end, NH on another end. So that is your repeat unit. That is showing a polyamide. D is the correct answer. Question 34, still on polymers. Which type of polymer is not hydrolyzed by heating with aqueous sodium hydroxide? So polyalkenes are addition polymers. They are non-polar. They are not broken down by acid or alkali. They're non-biodegradable. So A is the correct answer. Polyamides, polyesters and proteins. Polyamides and proteins have C double bond O NH. Polyesters have C double bond O single bond O. You have a polar bond in there, which allows it to be attacked by acids or alkalis, or nucleophiles in this case, which would allow them to be broken down or hydrolyzed. So B, C and D are all able to be broken down by NaOH. Question 35. What's the correct structure for a zwitterion of an amino acid? So for it to be a zwitterion, it's going to need no overall charge, where the COH becomes COO minus. It donates its proton to an adjacent amino acid, where the NH2 becomes NH3+. So going through the options here, which one is a zwitterion? It can't be A because you have two NH3 pluses. There is an overall positive charge. It can't be B because there is an overall negative charge. C, even though there's no overall charge, the positive charge is in the wrong place. D, you have NH3 plus and COO minus. No overall charge. That is indeed the correct structure for a zwitterion. So D is correct here. And finally, question 36. Which row shows a pair of bases that can link two strands of DNA with 3 hydrogen bonds? So adenine and thymine join together with 2 hydrogen bonds. Cytosine and guanine are linked together by 3 hydrogen bonds. So it has to be the one with 3 hydrogen bonds, that's in the question, so it's answer C, cytosine and guanine. So that brings me to the end of the 2021 paper 3. Hopefully that's helped you to understand how to get to the correct answer for the multiple choice questions. If you do want further clarification, please do drop a comment and I'll do my best to get back to you. Otherwise, best of luck with your exams.